I'd like to share some experience from the image analysis as a service at our Prague node that is part of the Czech bioimaging. We as the Prague node are part of the larger Czech bioimaging infrastructure. At the Prague node, there are currently 7 facilities. Actually, a new facility, Institute of Experimental Medicine, joined us last year, and they also do offer image analysis as a service. We are also involved in the European Open Science Cloud projects. However, there will be a presentation on Friday regarding the National Repository Platform that's built in the Czech Republic, so I will not go into further details right now. I would like to show you some examples of what exactly we do offer. We deal with light and electron microscopy data, so both of them, from cell lines, organoids to histological sections. We do some nowadays standard AI segmentation, like here in the example. We have nuclei segmented by cell pose, a pre-trained network. We also do training of the networks, like here in the other example. We have mitosegnet with a trained network. This one has been already published with very nice results. Now another one, we have omnipose segmentation that we connected with the tracking. There was actually an AI tracking tool called Delta. And here I have an example of the bacteria dividing. Then we constructed the lineage trees, depending also on the fluorescence intensity in 3 channels. So quite a complex project as this one was, and this is in preparation for publication. So I'll just show the video. Moving on, we also deal with some large data from light sheet and optical projection tomography. And we had established the whole workflow, starting from the stitching fusion, also including deconvolution of such large data, visualization and segmentation. You can see here an example of mouse embryo. And yeah, we nowadays are able to quite nicely deal and help you also if you need with processing of the large data. Here I have an example from the optical projection tomography. Here the aim was to quantify pancreatic islets for transplantation. So you can also use stereology methods and some 3D reconstructions. This is also then prepared now for the publication. We also offer some computations, like I have here some photo bleaching experiments. These are FRAP curves, and with a custom written scripts, we fitted all the curves with compartmental analysis. There has been also quite a complex projects. There was an inner user from the Institute of Molecular Genetics. Regarding the computation and programming, we also actually offer software development, and the newly joined Institute of Experimental Medicine, they built their own software for analysis of live cell fluorescence microscopy data. This is mostly focused on neuronal models, but it's quite easy to use. It's been written in MATLAB, so yeah, this has been a bit more specific, complicated task. But this is what they offer actually as an open source, so you can have a look at their website if you have such a type of data. We also deal with lifetime imaging data, and we have a custom written TTTR data analysis software. And here is a very nice example of the segmentation that included also the RGB coded film data. So they teach the neural networks also with the film data, and then they did object-based analysis. Here we have a phasor plot, and these crosses correspond to individual objects already from the segmentation. And the whole analysis, also statistics, has been performed on the object. So this might be quite a nice approach, interested for someone. We also work with electron microscopy data. Here is an example of large data processing. There was a semi-automated approach together with deep learning, and they use deep MIB for the final processing. And here on the right, you have Amira rendered model. So also such large data, we can help with processing of them. Also from the electron microscopy, another example from electron microscopy data, these are FIBSEM data and the segmentations. We can also offer this open access program pattern you can find on our website. This is for immunogold labeling analysis, point patterns. You can evaluate colocalizations and some statistical evaluation compared to random distributions. Here I have an example of mapping of the labeled areas. Now, regarding the image analysis as a service itself, so this is all modalities that we can offer regarding the analysis. Here I have an example of a project that actually took place in our facility. This was through the Euro-BioImaging and directly communicated with ASTA. We asked from Max Planck Institute of Psychiatry. They've had a study of behavior analysis of mice, stressed mice, and they mapped this via CFOS with light sheet. So they have these 12 brains imaged, that's quite a large data set, and they needed help with processing of such data. So the project itself included annotation to the LN Brain Atlas of these images and the segmentation of the CFOS signal, and then some simple statistical evaluation. And then they worked further with the results we gave them. So here I have an example of the result that was from this project. This is a density map of the brain area. So they gave us all of these images, and we gave them back final density maps and then text files with the results. The whole project took over the year to be executed, from September 2022 to, I think, October 2023. Included some test phase, then the execution of the project, and then final checking of the results and the report from our side. It took us all together around 100 hours to perform this project. So this was like a pilot one for us to set up all the services, how it works. So now we already know what we need to do, how to do all the planning, execution, monitoring, what to ask for. So this was for us a bit of a testing phase with the project. We actually use the virtual desktop infrastructure for the computations, and this is what we can offer for both internal and external users, because and it's really right now, this month or last month, it has been really open for all of the users of our facility. And this infrastructure has been built thanks to all of these national and European infrastructures that are listed here, starting from Czech bioimaging, Euro-BioImaging, Open Screen, Center for Phenogenomics, CESNet, and all of them have been involved to building this large data center. We have fast data storage and long-term storage available for the users, and we have now 13 virtual workstations available to work with. and also a dedicated server there for deconvolution. In more details, I have here one more slide with more details what we offer, because this can be really used also by external users, and you can externally connect and for some small payment use all of these machines and all of the listed software. So we have 13 virtual machines starting from the 12-core 64 gigabytes RAM to 1 terabyte RAM, 64 core, and here's the listed software. The commercial ones like the Imaris, NIS, Elements, Hycans. We have MATLAB, Arivis, CellSense, Zen, Lasix, also FlowJo, and of course we have there the Python and Fiji on each of the computers available. So maybe if you're interested, this might come handy for some of the users, also external ones, to remotely connect via Omnisa Horizon, and we use then Globus data transfer for transferring the data. So also externally. Now, what we also offer via Czech bioimaging is are the user projects, and these are not only microscopy projects, but these are also data analysis projects, and I mean purely data analysis projects. So we provide approximately 3,800 euro is the limit to support the costs, but really you can apply with your own data measured somewhere else on in some other facility, and just we can help you with the data analysis. And the deadline is on 15th April, so not much time, but if you're interested, you can have a look at the open call. We also do many microscopic courses, and I have highlighted those that deal with the image analysis. We offer the AI-based segmentation and tracking course that will be actually at IMG at our facility next month. Then there is planned the advanced 3D image visualization and quantification course. Also for volume EM data, advanced analysis and processing. If you're interested in more programming, then there will be Python for analysis and processing of images, and introduction to programming for image processing. That includes MATLAB as well in this case. So that will be all from my side. Thank you for your attention. On behalf of the group, I would like to thank you, and I'm open for questions.
Thank you very much, Michaela, for that fantastic talk and for sharing with us so many opportunities. It is really great to see the diversity of services that you offer, and also the funding opportunity. I'm sure people are very happy to hear about it. I must remark that your training courses are very, very varied, and it's really nice that you try to cover people at different levels of expertise with image analysis. We have a question in the chat from Mozart, who's asking if the courses are available online.
Some of them will have a look at it, but it's a good idea to open actually more of those image analysis courses online. I'm not really sure that all of them are available. Definitely some of them are, but that's a good idea. We'll have a look at that so that it will be more open.
Yeah, thank you, Madasar, for that idea. I think it's the amount we're getting used to being on Zoom.
Yeah.
Well, I guess so. It's something that we can certainly think about. All right. Are there any more questions? If people want to ask questions themselves, they can also put up their hand. If that's not the case, I would actually have a quick question for Michaela. Well, quick, I say, but I think it might be a tricky one. So I wonder, so this is more out of curiosity. when in the life cycle of the project do people mostly end up contacting you for image analysis? And you can also, of course, remark whether that is ideal or not. But in general, it would be nice to hear, like, when do people contact and when you'd rather people contact you for image analysis?
Yeah, of course, it would be best if people contacted us at the beginning, before starting imaging, because it's always for us the best practice, to discuss also the acquisition part. But of course, I understand that very often this is not the case, and you have the data, you start analyzing it, and then you realize that you need some help with this. So also in this pilot project, of course, the data is already taken, everything was acquired, and then after they tried themselves to analyze the data, after that they ask us for help. So in ideal case, really at the beginning of planning the project, in the starting phase. But of course, we'll then try our best if you have the data already acquired. Because then the issue is very often it's just not possible to acquire some of the images again. And it would be necessary, it would be nice, because there's something is very often missing in there. But yeah, that's how it is.
Indeed. But yes, I think for our users out there, maybe here's a pointer to think about going with your test data sets already to the image analysts, and maybe that will also help you to further develop your project. Are there any more questions to Michaela? If that's not the case, please feel free to add any questions in the chat as well. If they come up at a later point, in that case, please specify who the question is for. And with that, a big thank you to Michaela for sharing her experience with us. And we will move on to our next speaker. Thanks, Michaela.
Thank you.
All right, now it is again with immense pleasure that I introduce our next speaker, that is Jean-Yves Tineves, who is based at the Image Analysis Hub at Institut Pasteur in Paris. He is part of our French bioimaging node, and they have a very interesting architecture of image analysis node. So, well, we are looking forward to hearing from you, Jean-Yves. Please take it away.
Hello everyone, thank you so much, Asta, for your kind words.